My PhD was called an adaptive resonance classifier, and it had a much longer title earlier on. And then one of my supervisors said he wanted to save some gold ink because they put gold ink on the outside, and so it had to fit, you know. So just shrunk it down. Then there are standard statistical tests which are based on things like the number of measurements that you've taken, which determine whether or not the result that you're finding is statistically significant. Yeah. I think that's what you were referring to.
Well, yeah,
but enough measurements, and there has to be enough certainty in the result, and you sometimes need to use statistical tests to do that.
Well, yeah, I think a large part in my case, I mean, this is sort of one of the questions, how much should I go to that place? Because a large part of my PhD, for example, is just, can you make a heterogeneous object with 3D printers discretely? And if I can show that I can indeed do that, it either is or isn't. It's a binary state.
Point taken, point taken. So sometimes you can really get away without statistics, and one of the other sheets says something like the important missing word in computer science is logic. Underneath logic, and logic is the opposite of statistics. You're really saying something. You're taking a rational approach and saying it either works or it doesn't.
Yes. And I find also in computer science more towards, not always, but a lot of the engineering type of stuff, the computer engineering. Engineering, which is interesting, engineering methodologies are really different than even all the methodologies that were taught in the MRes here almost have no bearing on engineering PhDs, as far as I can tell. They're very separated and removed.
Yeah, that's a good point. What I'm trying to focus on today is those things that will be relevant in the broad sense of computing and computer science to your doctorate. Yeah. But there are a lot of other methodologies, of course, qualitative methodologies, some of which will also be relevant for much of your work. But that's not what we're talking about today. Elizabeth?
Every conclusion within the research must be supported by reason, reading, and data.
Okay, so I think they've said it already, but those are the three things that I can think of which are absolutely essential. Reason, that's the logic bit. Reading, as in literature review. And data, normally there's some kind of information that you're using that would support, because you're not doing a purely theoretical doctorate. So there must be, normally there'll be an empirical side to it. So, again, it's not that you have to use one particular formal method to draw your conclusions, but there must be elements of reason and reading and support from data in reaching those conclusions. It's just a very sort of general methodological point.
Or just support from experimentation.
Absolutely. For data, read, experiment. I mean, this experiments generate data.
Yes.
Yeah. But the data could come from else. It could come from your experiment. It could come from something else. Yeah. So that sounds like a contradiction in terms, but computing is it's just anything that involves computation in computers. So unless everything that you do with the computer is scientific, then obviously computing can be unscientific. Exactly what that means and what that means for any research methods is a bit of a minefield. But welcome to the minefield, I suppose, is what you could say. There's nothing wrong with that. You just have to think your way through it. Next one.
What is the core value of science?
Yeah, that's coming back to computer science, which is what I was asked to talk about computer science methodologies. And I would suggest that the most important word there is science, because, as we've said, we can talk about computing that isn't science. But if we're talking about a scientific approach, what is the core value of science? Is there a particular thing that must be shown or taken into account in doing scientific research, irrespective of the subject? Any views on that?
I think to approach to a repeatable results.
Repeatable results. It's very interesting. Bruce, do you agree? Repeatable results?
Yeah.
Are your results repeatable?
Sometimes.
somehow.
I think for me it's the constant willingness by a community to throw away old paradigms and move toward truths, or closer toward truths all the time.
Yes, yes.
So winnowing out.
Yes, yeah. The two statements are equally valid, I think, as possible core values of science, aren't they? And I'm sure there are many others. But repeatable experiments, repeatable results is important, but also throwing away, seeking a truth in some sense, seeking something that's closer to the truth than what we already possess in terms of knowledge. Repeatability is an interesting one, I think, because, for example, if you do the same experiment with your cohort of children on Wednesday and then on next Tuesday, will you get exactly the same results? No. But if you look at the statistics, will you get the same results? Probably not, because you've done the experiment with the children, they've learned about it, and they'll respond differently. If you go to that scale, I mean, you might actually be repeatable in the sense you might get similar results. But whether you want to do, but that doesn't mean to say that you have to do that. Your research might be about working with a particular cohort. It depends what you're trying to demonstrate. But your conclusions from that would have to take into account whether you're making statistical assertions about, I don't know, all children or all children in a particular circumstance, or just what can happen with one group of children. All of that may be irrelevant to what you're doing, but I'm just plucking an example out of the air.